Welcome to the sixth lecture of the bridge engineering. Right here, we'll see some of the examples. Right, we'll see some of the types of bridges in deep. Okay, so deep means what? We'll try to understand how it is and how they are constructed. We'll see highway bridges. In the highway bridges, we'll see permanent bridges. That is steel and RCC T-beam. These are two important types which is have been asked for the explain this type of bridges, right? So highway bridges are those bridges which are constructed on the highways, right? Those bridges which are constructed on the highways. The first type of the highway bridge is the T-beam bridge, right? This is how it looks, the structural form of the T-beam bridge, right? It's like a beam and slab junction. It is also called as T-beam. As you see in the construction of the houses, slab and beams are constructed simultaneously, monolithically. It feels, when you see the section of it, it looks like a T. Same way, here these bridges are being constructed with the help of the slab and beam junctions, monolithically constructed. So the span, when where you are going to use this, you are going to use the bridge T-beam bridges in case of the span is in between 10 to 20 meters. Each span of a bridge, each span in this bridge, the length of the bridge is different and the span of the bridge is different. Span is the length between the two intermediate supports. If you see in this case, the distance between this pier to this pier, whatever is the distance, right, that distance is called as span, right? So that span should be 10 to 20 meters. If it is in between 10 to 20 meters, then we are going to provide, we will go for RCC T-beam bridge. The bridge deck means this superstructure, the slab that we say, right? The slab which we provide above the beams or the girders, that is called as deck in the case of bridges. Consist of, this is called deck. Right? This part and this part, the above the beam there is slab, that both to combine is called as deck, right? The bridge deck essentially consists of concrete slab monolithically casted over a longitudinal girders, so that the T-beam effects prevail, means it looks like T-beam. T-beams is simply supported over the abutments and piers. It's like a slab that you provide in your houses, right? These are simply supported over the beams and piers and abutments. To impart transverse stiffness, the cross girders or the diaphragms are provided at regular interval, so that laterally it should make to be strong, because the length of the bridge and the span of the bridge is longer, 10-20 meters span it is there. So to avoid to have a lateral stiffness or lateral stability, if you they provide a lateral beams. These main beams are there along the perpendicular direction to the main beams. We provide a small girders, or you can say cross girders, or you can say diaphragms. In this image also it is there. If I try to show you here, can you see this? These are called cross girders or diaphragms, which are provided at regular intervals to provide lateral stability, right? If the thickness is more, then it is called as diaphragms. If the thickness of those beams are smaller, then it is called as cross girders, right? And the number of longitudinal girders depend upon the width of the road. In this case, the width is more, so the number of T girders or the T beams are more. This type of RCC bridges is cheaper than the slab bridge since it requires less quantity of material in construction. Right? If you only go for a slab bridge, then the depth of that slab will become very huge than this case, because we have to consider whole area of the width of the bridge. Right? So it becomes very expensive, and the quantity required in this case of the T-beam bridge are lesser. So what we studied, the span should be around, it looks like T-beam, right? It is a combination of slab and the beam, and the span should be around 10 to 20 meters. Then only you can use, like it should be monolithically casted. We are talking about the longitudinal or the main girders. This, right? This is your longitudinal or main girders, which go along the bridge. Right? For transverse stability or stiffness, we provide crossed girders or diaphragms, and these are these bridges require less quantity of material for construction. In that case of these slab bridges. Right. Next is the steel bridges. Right. So steel bridge is made up of steel. Right. It might be of any type. Steel bridges replace masonry and timber bridges. The steel bridges replaces the masonry or timber bridges, because it becomes very easy for fabrication. The construction work is at a very speed, because it doesn't require any curing period or such like that as it requires in the RCC. Right? Here fabricated in the factories, bring it to the site, just fix it, and it's done. It's not so easy also, but it is faster in that case of RCC bridges. When there is a time constraint, you can go for steel bridges. Use of steel is most common due to the fact its strength and durability. Okay, it also has a strength and durability. Compared to the concrete structure construction, the steel construction is super fast, light in weight, and reliable in faster constructions. As I said, it requires lesser time than as concrete bridges, and it is also light in weight with respect to the construction of RCC bridges. Further, the construction operation of the bridges at the site can be reduced with the steel superstructures by fabricated parts, components from the nearby factories. What I said, the parts are manufactured in the factories, nearby factories, and brought to the site, and just been connecting the parts together. It's the work to be done. Right? This is what is steel bridges are, and the length of this steel bridges, it can be depending upon the type of the steel bridge. It might be arch, it might be a beam type, or it might be a suspension bridge, steel suspension bridge. Depending upon that, the bridges span of the bridges depends. In the most of the case, it depends. It may vary from 10 to 30 meters of span. Right? We can go for in the case of steel bridges. These are the two major types of bridges that we use in the various type of construction of the bridge.